Alright, welcome back to Doki Circuit Club. This is the third episode, and we will be talking about the Demorgan'S circuit, basically proving one side of Demorgan's law, where the inverse of A and B has to equal the inverse of A, or the inverse of B. So, this is our circuit. As you can see, it has some similar components to the other lab, but it also has some new components. And I know you can't tell these two chips apart, but this is a NAND chip and this is an OR chip. So basically, what we're doing with this NAND chip is we're connecting it, much like the other lab. Instead of having an AND gate, a quad AND gate here, we have a quad NAND gate, which is basically connected to all the same spots as before. So what this basically will do for us, as you can see in this schematic, is when the switch is off, this is always going to be 0, and this is either going to be 0 or 1 since it's a timer. So since they won't be the same, well, they can be the same, but it's just going to be 0, 0. It won't ever be 1, 1, which is the only way you can get an AND gate to be 1. So this is just going to be inverse of 0, which is 1, which means this LED will always light up. This, for NAND 1, connected to the switch is 0, so this will be 1. It's an OR gate. If one side is 1, then it's always going to be 1. So LED, what is that, 3? Yeah, LED 3 will always light up 2. And this switch is just connected to the switch, so it won't light up. I mean, this LED is connected to the switch and won't light up. And as you can see here, this is the timer LED from last time. This is the switch LED, which won't light up if the switch is off. This is LED 2, I believe. And that's, you can see it's connected to this resistor, which is connected to the NAND gate. So yeah, that is LED 2. And this is LED 3, which is connected to the OR gate. And when the switch is on, this will be this side will be 1, and this side will either be 0 or 1. So there can be a 1, 1, but in this case, since it's a NAND gate, the times when it's going to be, well, it's going to fluctuate first of all, like the timer, but it won't fluctuate with the timer, if you understand what I'm trying to say. Because if it was an AND gate, then it would fluctuate with the timer, but we're inverting it. So for all the times where the timer is 0, it's going to be 1, vice versa, which is when this part will be 0, which is when it's going to be off. So that means this LED will just operate like the timer, but it won't be in sync with the timer. And for NAND 1, to connect to the switch, it's going to be on, so the switch is on, so this is just going to be inverse of 1, which is 0. So that's 0 for one side of the OR gate, and then this, NAND 2, connected to the timer, so it's either going to be 0 or 1, which means this OR gate is either going to be 1 or 0. So, like LED 2, it will fluctuate, because the OR gate's going to be 0, and either 0 and 1. So, when NAND 2 is 1, this OR gate will make this LED light up. But it also won't fluctuate with the timer because you're inverting this part. You're inverting NAND 2. So this is represented by this timer. So time to test our circuit. Right, well, that is really bright. So yeah, as you can see, this LED is blinking like the timer. These two bright LEDs are not blinking, but if I press the switch, you can see this LED is staying on constantly, which is the LED connected to the switch. And these two LEDs are fluctuating, but as you can see, they're not fluctuating with this LED because they're being inverted. Alright, and that is Doki Circuit Club, episode 3. Unfortunately, this might have to be the end of the series, since for the foreseeable future we won't be having these physical labs. So it was an honor enlightening you with the joys of circuit physics. And this is me signing out.